Assalamualaikum and good day, sir. My name is Wan Nazifa Azul binti Wan Azman and my matric number is 288197 and I will present about the implicit function theorem. Implicit function theorem provides a formula for calculating the derivative of the implicitly defined function. It involves the partial derivative of f(xy) with respect to x and y, solving for dy over dx. Here's the condition 1. Show us the example of explicit and implicit function with one choice variables. And condition 2. Show us the example of explicit and implicit function with more than one variable.
Next, I will talk about the Jacobian metric function, also known as the derivative matrix or the Jacobian metric. It's a mathematical construct used in calculus and vector calculus to represent the partial derivative of a vector value function with respect to its input variables. It plays a crucial role in multivariable calculus, optimization, and differential geometry. The Jacobian metric can be used in various applications, including calculating gradients. The transpose of the Jacobian metric can be used to calculate the gradient of f, which provides the direction of steepest ascent in multivariable optimization problems. Secondly, change of variables. When performing a change of variables in multiple integration or coordinate transformations, the Jacobian metric helps account for the stretching and rotation of the coordinate system. Next, linearization. The Jacobian metric allows linear approximations of the function near a point. The first order Taylor expansion of f can be expressed using the Jacobian matrix. Overall, the Jacobian metric function provides a way to analyze and understand the relationship between variables in vector value functions, enabling the study of complex systems and the development of mathematical models.
Hi, my name is Nur Aimin Najal and my metric number is 295218. For the first condition, the first step is to convert the equilibrium condition into equation. As shown in the picture, we can say that each of function in f1, which is the consumption function, investment function, and import function, has a continuous derivative. Thus, we can conclude that f1 have a continuous partial derivative with respect to each variable. Besides, each of the function in f2, which is the money demand function, has a continuous partial derivative. Hence, we can conclude that f2 also have a continuous partial derivative with respect to each variable. It's follows that f1 and f2 have a continuous partial derivative with respect to each variable. Therefore, the first condition is satisfied. These two equation systems satisfy first condition of the implicit function theorem because the f1 and f2 have the continuous partial derivative. For the second condition, we can do the Jacobian determinant. The Jacobian determinant is absolute value of the 2 by 2 matrix with entries representing the partial derivative of function f1 and f2 with respect to the variable y and r. So, for the format of the Jacobian determinant is equal to the partial derivative of f1 with respect to y, the partial derivative of f1 with respect to r, the partial derivative of f2 with respect to y, and the partial derivative of f2 with respect to r. So, input the value into the format and become 1 minus the derivative of c with respect to yd plus the derivative of m with respect to y, negative derivative of l, negative derivative of I with respect to r, the partial derivative of l with respect to y, and the partial derivative of l with respect to r. So the answer that we can get is negative, which is less than 0 and non-singular. Since the Jacobian determinant is non-zero, no matter where it evaluate, the second condition is satisfied.
Good day, Dr. Adams. My name is Lim Heling, non-metric 294414. Now, I would like to continue discuss the part B using the integration function rules derive the expression for delta y star respect to delta t0 and delta r star respect to delta t0 and solve the algebra signs for each partial derivative. First of all, if we want to obtain delta y star respect to delta t0 and delta r star respect to delta t0, all exogenous variables must be constant except t0 and differentiate it. After we differentiate it, we have to dividing delta t0 so we can correct the terms and proceed the Jacobian metric forms. After we proceed the set 2, so we continue to form a Jacobian metric forms. For your analysis, the green highlighted and the blue highlighted area actually is the x and y. If you recall the learn from the intro to mathematics economics, the general Jacobian metric form actually is the same things. So we substitute the green highlighted area into the place we normally put for the x, and the blue highlighted area we put the place which normally we put for the y. So we continue form a Jacobian forms and try to differentiate each of the terms. After we form the Jacobian metric form, now we can find the determinant of Jacobian. The formula is AD minus BC, so we substitute all the AD minus BC, and how we evaluate it. We can evaluate it based on the condition given by the questions, and you can refer the solution step by step for me, and finally we get the value is negative value, so it is proved that the determinant of Jacobian is not equal to 0, so it is not singular. So we find out the determinant of Jacobian metric form. Now we have to find out delta y star respect to delta t0 by using Cramer rule. By using Cramer rule, we have to substitute the first column, and the same formula using is AD minus BC, and after that we substitute the AD minus BC and gain the value, positive value, which based on the condition given by the questions. Now we finally have to find out the delta y star respect to delta t0. Actually, determinant of Jacobian respect to y dividing determinant of Jacobian is actually equal to the value of delta y star respect to delta t0. So we substitute the value we gain from the set 4 and the set 5. Now we gain the negative value. Therefore, delta y star respect to delta t0 is negative relationship between income y star and tax t0. So we can conclude that when the tax increase, the income will decrease.
Next, for question 2b, we skip step 1 till step 4 because we already got the determinant of J from the previous question, which turned out as negative. Then we proceed to step 5 to find delta R star over delta T0 by using Cramer rule, and it turns out as positive. Therefore, delta R star over delta T0 is negative sign. It means that negative relationship between interest rate and tax. So, in a conclusion, when tax increase, interest rate will decrease. That's all from me. Thank you.